Please start out by answering the question on our summary slide. What did we learn yesterday? Or what did we learn in our previous lesson? Now moving on to our new lesson, our learning target says, I can compare the slopes to determine if lines are parallel, perpendicular, or neither. And the essential question asks how you do that. So the key word here is slope. We are going to focus on the slope of the lines, and I'm going to teach you how you can figure out by drawing a graph or by just looking at the equations whether lines are parallel or perpendicular or neither. So parallel lines look like this, and I know you've worked with them before. Parallel lines do not intersect. They don't cross. And the reason that happens is because their slopes are the same or equal. They're slanted the exact same amount. So the steepness of the lines, if it's exactly the same, they're not going to intersect with each other. So these are lines that do not cross. Okay, so parallel lines are lines that do not cross, and you see that in their equations because they have the same slope. So if I write two equations here, and I'm just making them up, y equals 2x minus 1 and y equals 2x plus 5 are my two equations. As long as I keep the slope the same, the lines are going to be parallel. So I've highlighted in green to show you the slope of each of those lines. All right, now perpendicular lines, these are a little bit trickier to work with. I know that you are familiar with perpendicular lines as well because they're very common. Perpendicular lines are lines that intersect at 90-degree angles. So they intersect at right angles. So not only do they cross, but they cross at right angles. Now this happens, if you're looking at the slope again, this happens when the slopes flip and change. So they are opposite signs and reciprocals. And then another way that you could look at it is the product of the two slopes is -1. So that might be a little trickier to think about. Okay, so these are lines that cross at 90-degree angles. Parallel and perpendicular lines are seen everywhere. If you look at the ceiling in our classroom, you see parallel and perpendicular tiles. If you look at the walls, if you look at the squares on the floor, if you look at a map and you see streets, a lot of times they're parallel and perpendicular because that's the safest kind of an intersection for driving. So perpendicular lines, slopes that flip and change. So if I make up one equation like this, and I'm just making up anything that I want, then I take that slope, so my slope is 2/3. If I flip it over and change the sign, it's going to look like this, -3/2. And the intercept doesn't matter. So I'm just picking any number, positive or negative, for the intercept. Those don't matter at all. Okay, so on the next slide, I'm just going to reinforce this a little bit. After the y slide. So then it says we wrote equations in point slope form. Now, actually, we're not going to do these two things yet. We're just going to do this today. We'll do that 1 and 2, the parallel and perpendicular. We'll do that tomorrow. So looking at this artwork though, this is just an example where they've created a design and they really are using a lot of parallel and perpendicular segments. Okay, so now on this next slide, I have some equations for lines, and we are just going to practice writing an equation for a line that's parallel or writing an equation for a line that's perpendicular. So my first line, the slope is -3. So if I am going to write an equation for a line parallel to it, I just have to keep that slope the same. So I can write whatever I want for the intercept, as long as I don't keep it positive 7. So my slope is negative 3. I've kept it the same. And then the intercept can be anything I want. So maybe I'll do plus 6. Okay. So that's writing an equation for a line parallel to it. Now I'm going to do that for the next one. Same thing. I'm going to keep my slope the same. And I'm just going to change the intercept. There. Same slope, parallel lines. Next one, same thing. And remember, in front of the x, you can put that 1 there, that invisible 1. And then change my intercept again. Okay, so parallel slopes stay the same. Now, the next two equations, you can't tell what the slope is right away. We're going to have to do a little bit of work, and we know how to do this. We're going to do a little bit of work to figure out the slope. So we're going to write our equation in slope-intercept form. So remember that on this first one means getting y by itself. So we just divide everything by 2. So y equals negative 3x plus 5. You need to do that to figure out what your slope is before you can write your equation parallel. So now keep the slope negative 3, change the intercept, done. All right, the bottom one requires a little more work, so it's going to take 2 steps to figure out what the slope is. First, I need to add the 2x to both sides. So 3y equals 2x plus 6. Remember, those aren't like terms. You can't put them together and get 8x. Then I would have to divide everything by 3. And also remember that I wrote this in a specific order, slope-intercept order. So after my equal sign, I did put the term with the x right after the equal sign, and then after that, the plain number. Okay, so now I can write my last parallel equation. So this slope needs to stay 2/3, and then change the intercept. And how about if I don't even put an intercept there? My intercept could be 0. All right, so we've got 5 examples there of just writing a line that's parallel to a given line. Just writing a line. Okay, now we're going to change and we're going to make it perpendicular. So if my original slope was negative 3 and I put a 1 under it, that's going to help me see what it looks like as a fraction, because I have to flip it over and change the sign. So instead of negative 3 over 1, I need to make it positive 1 over 3 for the perpendicular. So now I've changed my slope. So I'm going to change my color here. There we go. So that's going to be perpendicular. Okay, next one. Flip it over, change the sign. Negative 2 over 3 turns into positive 3 over 2. And I can pick anything I want for my intercept. All right, next one. 1 is the same as 1 over 1. So if I flip it over and change the sign, instead of positive 1 over 1, it'll be negative 1 over 1. So this would just be negative 1 for the perpendicular slope. Next, negative 3, put a 1 under it. So this one's going to be positive 1/3 when I flip it and change the sign. And then the last one, flip it and change the sign, it'll be negative 3 over 2. Okay. Now, let's compare some lines that are given. So this was writing our own equation parallel or our own equation perpendicular. Now we're given 2 lines and we just have to figure out what kind of lines they are. So let's take it one equation at a time. Solve it to figure out the equation in slope-intercept form. So this is review. So y equals 3x plus 1 when I simplify it. Okay, so my purple line, y equals 3x plus 1, I'm going to show you on the graph what it would look like. I start at 1, and I go up 3 over 1 for my slope. So here's my purple line. Okay, and then my other line is already in slope-intercept form. So I'm going to graph this one in red. This one starts at -4. And the slope is up 3 over 1. So you should see that these lines are parallel. So they have the same slope. So here is my slope, and here is my slope. So you don't have to draw a graph, but I just wanted to show you what they look like on a graph. Okay, next one, same thing. So rewrite the first equation. So this is a review from 4.1, putting our equation in slope-intercept form. So this one is y equals -4x plus 3. So I would start at 3, and then my slope, I'm going down 4 over 1, and then I draw my line. Okay, so here's this slope. Then my other line, I'm going to switch my color. Y equals 4x plus 1. So I start at 1, and I'm going to go up 4 over 1. So here's my line. So these lines, that wasn't the best line. Let's see if I can fix it. There we go. That's better. Okay, so these lines, they intersect, but they're not intersecting at a 90-degree angle. So these are neither. When you compare these slopes, one was +4 over 1 and one was -4 over 1. It didn't flip over. Remember, it's got to be the opposite sign and the reciprocal. Okay, last one. One of them to rewrite again, and this is just one step, so take away 3x on both sides. So y equals -3x plus 12. Okay, so this one I'm going to run out of room on my graph. Sorry about that. But 12 is going to be up here. And then I'm going down 3 over 1. So maybe if I just kind of make it go down here instead of starting at this intercept, it'll be more accurate. Okay. So here's my first line. And then my second one is 1/3 x plus 2. So I start at 2, and I'm going up 1 over 3. So take a look at these. These are perpendicular, because if I put a 1 under this slope, it flipped over and changed signs. So these are perpendicular lines. All right. Now on our last two slides, we're just using the slope formula to figure out if some segments are parallel or perpendicular. So we've got two different segments here. So AD and BE. So we have to find their slopes using the slope formula. So if I'm going to start with A and D, remember you subtract y coordinates on the top and x coordinates on the bottom. So this would be 5 over 2. And then BE, same thing, subtract y coordinates on the top and x coordinates on the bottom. So 1 minus 3, 7 minus 2. So -2/5. So they are perpendicular. So just use the slope formula to answer the question.